Alright everybody, here's what I think will be the last video in the series over secant lines, tangent lines, etc. In this last one we figure out how do you calculate the derivative. The derivative is also called by notation f prime. Okay? And quick reminder, so as far as the elements that are involved in this, f of x is the curve, the graph. F of x is some original function or formula, and f prime is this thing that tells you the slope of that curve. All right, and all that's, as far as the basic concept there, that's been covered in the videos leading up to this point. In the videos I've showed you already, here's an example of one of the problems that I showed you. The curve is given, and then I also give you the derivative. I told you don't worry about finding that right now, just because I wanted to keep it as simple as I could. And if we talked about how you found that in addition to doing everything else, it would have really muddied the waters more than they already are. Okay, so all right, yes, we didn't worry about how to find the derivative, y prime or f prime, and now we talk about how you figure it out. How do we calculate f prime if it's not given? Answer, you use that formula. That's one way. There are other ways to do it. This is the way that everybody learns first, though. Okay? So it's a limit. Limit h goes to 0 of f of x plus h minus f of x over h. Okay? And if you're happy to take that formula at face value, then you can do it. You know, it wouldn't be right of me if I didn't explain the origin of this formula, though. That's, everybody should understand where this comes from. So imagine it like this. We have a curve, and say I take two distant points. And just for purposes of this being abstract, this point is x, this point is a little bit to the right, let's say, and it's x plus h. The plus h gives some separation between these. If I take a number x and I add something to it, it's going to be bigger, and so it's going to be over here. And then this point then on that curve is going to be x, and the y coordinate is going to be f of x, what you get when you plug x in to this formula. This point is going to be x plus h for the x coordinate, and then f of x plus h for the y coordinate. Okay? And there I've drawn the secant line through those points. The slope of that secant line, I mean, we've done this so many times at this point. It's rise over run. You take the y coordinates and you subtract them, and then the x coordinates and you subtract them. If you did that for that line right there, you would get this, f of x plus h minus f of x over h. Now, do you see why this could tell you the slope of the curve? Like, how could I tell you the slope right at that point right there? I would have to do this, but I would have to push this point right up against that one. That's what the limit as h goes to 0 does. So this part is the slope of the secant line between two distant points, and that limit pushes them right up against each other. Now, if that's not enough, I can show you one more thing. In another video, I did this problem where I said, say you got that curve. Tell me the slope at the point where x is 4. Well, okay. The derivative was 2x. We put 4 in. We got 8. Okay, so the slope of the curve right there at that point where x is 4, it's 8. Now, the next question, though, I said, well, all right, what's the slope of the secant line through the curve that goes through the points 3.9 and 4.01? Aren't those points really close to each other? And so whether I find the slope of the curve at this exact point where x is 4, or whether I find the slope of the secant line between these two points that are really close to that one, I should get about the same thing. And I did. So that's what is happening here. That's what this does. This part finds the slope of the secant line between two distant points, and then the limit pushes them right up against each other. And then you get the slope of the curve at that spot. If you push this point right up against that one, you'll tell me how steep the curve is right there in the vicinity of that point. All right. So hopefully with me explaining it that way, you can see why the formula does what it's supposed to do, meaning calculate the slope of the curve. The hard part is in actually working this out, okay? So here's a real typical kind of question for us. Here is a curve, f of x is x squared minus 2x. Can you calculate f prime? All right. Okay, so let's run through how you do that after some adjustments. Okay, here we go. F prime is going to be, what did that thing say? Limit h goes to 0, and then f of x plus h minus f of x over h. Okay? All right. Now I need to figure out what is all that stuff for this function. F of x is just the function, and h is just this variable that we're controlling by the limit. What's f of x plus h? Well, that's like what would you get if you put x plus h in for x? Maybe I should make a big deal out of this. I could say, do you see this formula? F of x is equal to x squared minus 2x. How would you put a number in such as 6? Wouldn't you understand this formula roughly like this? X is where the input to the formula goes. It's the input squared minus 2 times the input. Maybe so that we don't get all the x's everywhere distracting each other, I'll just leave empty spaces. I'll put that to be empty and that to be empty because that's where you plug stuff in. So if I was going to plug 6 in, I would say 6 squared minus 2 times 6. That's where the input goes, if the input is 6. So 6 squared minus 2 times 6, right? And then you do the math. Now, I'm here to say right now that f of x plus h is no different than f of 6. X plus h is the input. It goes where the input is supposed to go. You can think of the function as, I erase the x. That's where the input goes. Maybe try looking at it like that. Whatever you plug into the function, whether it be 6, a number, or x plus h, or anything, it goes here and it goes there. And you square it, you subtract, you multiply by 2. So it would be x plus h squared minus 2 x plus h. That's what f of x plus h is. Okay, now that's a little bit of a side note. Maybe you didn't need me to tell you that. Maybe you did. My experience, most people need me to tell them that and explain it that way. So, okay. So let's do this. Let's write all of our stuff down. So we want limit h goes to 0. F of x plus h is going to be x plus h squared minus 2 x plus h. And then I subtract f of x, which is x squared minus 2x, and divide that by h. This subtraction must apply to that entire thing, whatever it is. So I wrote the subtraction, I wrote a parentheses. Now this limit, you can try plugging the 0 in for h in order to figure out the limit. It's not going to work though, okay? So what we need to do is simplify this thing right here as much as we can, and then we can do the limit. All right, so here goes. Here's what simplifying this is going to involve. Squaring this out, multiplying that by 2, distributing this minus in there. We're going to have to do all that stuff, reduce it down to lowest terms. All right, so if I do this squaring, x plus h squared, I'll get x squared plus 2xh plus h squared. And then if I distribute this negative 2, I'll get negative 2x minus 2h. And if I distribute this subtraction, I'll get negative x squared plus 2x. Now, when you do that, you'll find a lot of this stuff does cancel. Such as the x squared cancels with this one. The negative 2x cancels with this one. And we have some stuff that's left over, but let's see. Let's collect it all together and have another look at it. So I get, after my little bit of algebra is done and some canceling is done, I get 2xh plus h squared minus 2h. Okay? All right, over h. Now, I can reduce this further. I could see this, that everything there gets divided by h. In other words, you could, for the sake of reducing this a little bit more, you could see it this way. 2xh over h plus h squared over h minus 2h over h. So why can you do that? Well, because I can combine these three fractions. They have a common denominator of h. I can add and subtract them together. And if I do, I'll end up back up there. So I could take it the other way. Just don't start crossing stuff out, right? You look at it like this. This splits apart into those three things. Here, one h will cancel. There, another. And there, another. Okay? If I do that, if I take this and break it down that way, and I cancel the h's appropriately, individually right here, then this is what I'll end up with. Limit h goes to 0, 2x plus h minus 2. Okay, now I've done all the simplifying that I can. It's at this point that I can figure out what this limit is by pushing the h all the way to 0. So like right there, that h, what if that went to 0? What if it went away? What if you put a 0 right there? Then you'd get 2x minus 2. All right, so that's our derivative. F prime, the derivative, the formula that will calculate the slope of that curve at any point is 2x minus 2. Okay? All right, so what are the features of this? Well, you got to know the formula. You have to put everything into the formula the right way, and then there will be some algebra from there, right? And it should be stuff that you've seen. You know how to FOIL multiplication and combine like terms, and we talked about how you do the canceling right there. But all right, if we need to, we can talk more about it. That's how it's going to look, though. Okay? All right. So let's do one more of these that is based on quite a different original formula. So you get this. F of x, your original curve, your original function, 3 root x minus 1. What is the derivative of that? Okay. So, well, you know how to start this. It'll be limit h goes to 0. I'll go ahead and write it. I mean, I know I wrote it on the last one, but here's that formula that I introduced you to. F of x plus h minus f of x over h. What this formula does, well, I'll take a chance to remind you. It calculates the slope of the secant line between two distant points, and it pushes them together, therefore finding the slope of the curve. All right? In this case, the f of x plus h is, well, what if you took that formula and you put x plus h in for the x? You get 3 root x plus h. Okay. Minus 1. So there's f of x plus h right there. Minus f of x over h. Right? So this part right here, that's f of x plus h. This is obviously that minus that's built into the formula. And this part right here That's f of x. Okay, so do you see everything? Do you see everything here matches up with that one? Okay, now again, to do this limit, you can try just putting 0 in for h, but it won't work. Okay, you'll get an undefined expression. You'll get 0 over 0. So we have to simplify this. First thing I'll do is this. I'll say limit h goes to 0. Let me just distribute this subtraction. 3 root x plus h minus 1 minus 3 root x plus 1. Okay. And then I see that the 1's cancel. All right. So I'm going to get limit h goes to 0. 3 root x plus h minus 3 root x over h. Okay. Now, before, like, probably lesson 3 or so, we talked about how you can do limits like this that involve roots. And the whole trick to simplifying it was to multiply by the conjugate. So to simplify this any further, the thing I'm going to need to do is multiply it by the conjugate. So that would be, in my case, 3 root x plus h plus 3 root x. And down here, same thing. 3 root x plus h, 3 root x. I'm multiplying by 1, but I'm doing that in a way that it allows me to simplify this component of the expression with the square root. Okay, so yes, that's the trick. Now, we've seen that before. In fact, I showed you that before just so that when we got to this, we know how to handle it. But yes, that part, this or something like it, we've seen before. Anyway, so let's see. How is that going to work out? What if you multiply these together? Use FOIL multiplication. Okay. If we do that, I'm going to get 3 root x times, or 3 root x plus h times 3 root x plus h. Well, the 3 times 3, that's going to be 9. And then root x plus h times itself, that will be x plus h. Okay? So that's the first. The outside and the inside will cancel. And then I'll get, for the last, minus negative times a positive. 3 times 3 again, 9. Root x times root x, x. Down here, I could multiply all these together, but it will obscure what is going to cancel out of it. So I won't multiply them together. I'll leave the h out, and I'll just say it multiplies this. Okay, so like that. So I'll leave them apart, in other words. Now, okay, what else can we do? Like when we do this, we have to keep asking, what else can we do? What else cancels? What else can we combine? Imagine if you distributed that 9. It would be 9x plus 9h minus 9x. Oh, the 9x's are going to cancel. We'll get 9h. That's all that's going to be left on top. Then we'll get an h down here. A 3 root x plus h plus 3 root x. Okay? And then, you know how I didn't multiply these together? Because I left it like that, because I left them apart, it's like right in front of us, obvious that the h's now cancel, right? If I would have multiplied all that in there, it would have been harder to see that. So that's why I left it apart. So, okay, say the h's cancel. I get limit h goes to 0. I'll just have a 9 up there. And then down here, I'll get what you see. 3 root x plus h plus 3 root x. Now, it's at this point that you can find this limit by pushing the h all the way to 0. We're to the point where you can do it that way. If I push h all the way to 0, that becomes 0, right? H goes to 0. Say it goes, all that goes away, it goes to 0. Then I'm going to get 9 on top. And this part now is 3 root x plus 0. So it's going to be 3 root x plus another 3 root x. I can add those. That would be 6 root x. But then I can reduce. 9 on top, 6 on the bottom. Reduce by a factor of 3. I'll get 3, 2 root x. Then we're done. All right, quick overview. Start with the formula. Put everything into the formula the right way. Some initial algebra. We have to know how to work with expressions with roots, with limits. I introduce the conjugate. I do more algebra, more simplifying, but once we got here, we do this limit just by plugging in. It's at this point where we can do that. And then we work it out. That's what we get. Okay? My final answer, the derivative. The formula that will calculate the slope of that original curve at any point is right here. This thing. You want to know the slope of this curve at some specific point, then it goes into f prime. Take that point, put it in here. That's what the derivative does.